All right, guys. We're going to continue with the 5.6 notes. And so we're kind of on the next page from where the last video left off. So if you did not get to see that first part of the lesson where we graphed a polar function, you need to go back and do that. But in this video, we're going to talk about a little bit more of what the AP style questions are going to be like when it applies to these types of graphs. So first things first, y'all see this little paragraph up here, basically just saying that in the exam for AP Precalculus, you don't have to actually graph these things by hand. You can just have multiple choice questions. That's what they're going to be like on the test. So you'll be able to maybe identify different types of graphs and use those patterns in order to identify some functions. So if you can recognize certain patterns, it will make this type of thing much easier for you. So the activity that I had assigned you guys on Desmos, if you haven't had a chance to do it, I would suggest that you go and do that because it does help you to kind of start seeing some of the patterns that are associated with the different types of functions. So it will make identifying these graphs a lot easier. Now, if you don't have a lot of luck with just recognizing patterns, or if you forget the patterns, what we're going to do here is kind of talk about a way to be able to use your multiple choice answer options to your advantage to help you know what your answer choices are. But it is using a little bit of a different technique. So you're not just, it's honestly just using the fact that it's multiple choice to help you answer it. But honestly, it's not the most efficient method. So if you can get used to the patterns and being able to recognize all of that, it honestly will make it a whole lot quicker. Such as for this function, I see that there are 3 little petals, right? And so that tells me that there's that odd number of petals. To me, that tells me that we're going to have a 3 inside of the function that's being multiplied times theta. Now you're going to see that in every answer choice. Okay, but the 3 petals signify that to me. Now we see 2 that have sine, 2 that say cosine. And the easiest way to tell if it's going to be sine or cosine is you can look, does it hit the x-axis or does it not? Or does it hit the x-axis like at the maximum, like furthest out point at that radius? And so like if you look here, that radius, it should hit at 3. If it was cosine, it would hit right here on that polar axis, not x-axis, but that polar axis, the horizontal one, at a value of 3, and it does not, which that signifies it's not cosine to me, okay? And then that puts me between sine, the 2 sine options. And then you can go from there, kind of recognize some patterns. Where does this thing hit your y-axis? Does it hit up at +3 or down at -3? That kind of thing. And so anyways, that's just kind of like a way to go about it. It is not the only way, but it is a way. Okay. So definitely we want to be on the lookout for those types of patterns. But if that does not help, if recognizing those patterns does not actually help, then the alternative is I would plug a number in. Okay, so this ties very simply into what we did in the last video, plugging in values to the function and then seeing what the outputs are. But what we're going to do is plug in the values, see if we have a point on the graph. If so, then that's a possible answer. If not, then it's not. And it can be sometimes that you could narrow this down to being, say, it's cosine, or it's not cosine, it'll be sine. Okay, but which one is this? I can't remember if it's supposed to hit at the positive side or the bottom, negative side, which one. So here's what my suggestion is. My suggestion is to plug in a value that in theory would work. So I'm looking at this and I see like this pi/6 might have a nice answer. Okay, so because out here it would hit at 3. So if I plugged in pi/6, do I get 3 or something else that may be on the graph? Okay, so that's what I'm going to start with and just kind of see where that goes from there. All right, I'm getting a pen. Like I said, we're going to try plugging in a number. such as pi over 6. I'm going to do pi over 6 because I think that one is possibly going to be beneficial, okay? And it's just, I looked at the graph and I said, okay, that one might be helpful. It's not guaranteed, right? Because they can name that same exact angle with infinite other ways, but just, keep that in mind. All right, let's plug stuff in. Let's say f of pi over 6. Now, if you have a calculator, you can just type this in. If you don't, then I would just have to work it by hand. So that's what I'm going to have to do right here, because we're going to assume that we don't have a calculator. That's always going to be safest, since sometimes you do and sometimes you don't. So if I was going to multiply this, I would go ahead and just cancel with the 3 and the 6. Okay, 3 goes into 6 twice, so that denominator turns into a 2. That yellow is not the best color in the world, but turns into a 2 down here. Okay. So when I multiply this out, I get 3 times the sine of pi over 2. You got to know from your unit circle at pi over 2, what is sine? What's the y value? And at pi over 2, that y value is 1. So when I plugged in pi over 6, I got an output of 3, which does match here. Now, let's try the other one and say, do I get a similar situation or is it different? Because if I get multiple that work, then maybe I need to try a different angle. This is -3 sine 3 times pi over 6. Okay, so same situation. The 3 and the 6 will cancel. So really, I'm looking at -3 sine of pi over 2. Sine of pi over 2 we said was 1. So my output here would be a -3. So the way I can check if this is true is I'm going to look at the point for theta being pi over 6 and r being -3. Okay, well, that would bring me at pi over 6 is this little spoke right here, but -3 would mean it would go the opposite direction. There's not a point there. The other way to look at it is to say, okay, go go to r where it's -3, which would be over here, and then go pi over 6. It's positive, so it'd have to go counterclockwise. Again, landing you right here, and that is not the point on the graph. So this is not the answer because that point is not on the graph. And you can do the same thing with these other ones. So that point was a pretty decent one to use. I'm going to keep using it and just see. Cosine 3 times pi over 6. Now remember, 3 times pi over 6, we've already done that math. That is pi over 2. Cosine at pi over 2 is 0. And so really we're looking at pi over 6, 0. Well, at pi over 6, our radius is not 0, right? So that can't be it either. And just for good measure, this last one, we got -3 cosine 3. I'm running out of room, pi over 6. Okay, but again, this is -3 times cosine of pi over 2, which is times 0. And you get 0. So again, pi over 6 and 0, that is not a point on the graph, leaving you with answer option A. However, like I said, you see how this is not very efficient. This is a fallback in case being able to recognize the patterns does not work out for you very well. So I see the 3 petals. That is a good indicator about the number on the inside with theta. You got to remember that if it was an even number of petals, you need to cut the petals in half, and that's the number inside. So that's a little bit of a trick you have to remember. If you haven't done that Desmos activity, I would do it because you'll start noticing some of those patterns. And then you have to think about the difference between sine and cosine. So sine, you're going to see it hit. Hold on, pause. Okay, I got past the announcement. I'm back. So if we do the Desmos activity, again, like I said, you'll start noticing some of those patterns. Sine and cosine will hit the axes differently, and so you'll notice those patterns as well to help be able to recognize them without doing so much work. But again, if you can't remember the patterns, or if the patterns are hard for you to grasp, this is your fallback method. Since it is always going to be multiple choice, you should be able to do that. Okay, let's do another one. I actually want you guys to pause the video and try this one for me really quick. And let's just see if you get the right thing, because it's possible you'll get it between a couple different ones. I don't know. So y'all pause this one, try it, and come back. I don't know what value you guys tried. Hopefully you've already given this a shot, but I'm going to try using pi over 2. I think that that's going to be fair. Pi over 2, I know that doesn't seem like that's going to be a super strong indicator, but I want you to look at the pi over 3 measurement where there's actually 2 places. If I plugged in pi over 3 and I got one of those 2 places, then I don't know which graph it's going to be. Do you know what I mean? Like, so you'd have to then still plug that into multiple and then find another point to plug in as well. To me, I'm seeing this and I'm thinking, okay, that might be worth it. You also could try plugging in like a 0. I don't know if you'll notice here, but on the where the theta would be 0 on this axis, it's hitting at 2. So if you plugged in a 0, it's possible that you'll end up seeing a value there, not guaranteed, because it could still be between 2 points. So you've got to kind of like play with it, think about what you want to try plugging in. It might even be safer to try plugging in like a pi. I don't know. So you could try and then just see what happens. I'm going to try pi over 2. I think that that's the safest one, because that's the one where I don't see something for up here. And so I'd like to know, is it hitting 0 there, or are we hitting down here, or like, what are we doing? So that's what I did. Okay, so if I plug in, I'm going to say try theta equals pi over 2. That's my suggestion. Okay, so I'm going to do f of pi over 2 equals 2 plus 4 sine pi over 2. Okay. I don't have a lot of space here, so I'm going to do a little bit of this in my head. I'm hoping you already tried it, so it makes it easier. Sine of pi over 2, the y value is 1. 1 times 4 is 4. When you add those, we get 6. So I'm looking at being at pi over 2, 6. Now pi over 2, that would have been here. 6 would have brought me all the way up to the top. I know that's off the screen a little bit, but that's not on the graph. Okay, pi over 2, 6 is way up here at the very top, and that's not part of my graph. Nope. Okay, so then try f of pi over 2 for this one, 2 minus 4 sine pi over 2. Now, I've already done a little bit of this. Remember, we did 4 sine pi over 2 already, and that number came out to be 4. So 2 minus 4. 2 minus 4 is a negative 2. And let's see if that's on the graph. So at pi over 2, are we at negative 2? Yes. Again, the other way that you could do that is look at negative 2. So you'd be going this way, negative 2. And then pi over 2 would swing you counterclockwise that much. And that gives you this little point here on the inner loop. Okay, so this is good. I might have to check another point, but I'm going to go ahead and switch to the next thing and check and see if we can narrow it down just using pi over 2. All right, pi over 2 cosine is going to be 0. 4 times 0 is 0. And then 2 plus 0, 2. Okay, so at pi over 2, right, are we at 2? No, not on my graph. Bye. Next one, f of pi over 2 equals 2 minus 4 cosine pi over 2. Again, cosine pi over 2 is going to be 0. 0 times 4 is 0. So I get 2 again. And we already established that this is not a point on the graph. So the only one where this actually worked was this guy. If you had plugged in a pi over 3, it's possible that you got another one to work. But just keep that in mind, is like you can't always narrow it down just with one point. So I did here just because I picked a good one. But if you pick something different, you got to make sure that it's not working for multiple. Okay, now this is going to bring me to the more interesting, weird questions. Okay, when it comes to your AP test, if they ask you weird stuff like this, where they restrict the domain like that, see here they're saying like they've only given me a part of the graph. I'm not seeing the whole thing. Now, if you get to the point where you're like really comfortable with these graphs, you do enough of it to like understand the domains and stuff like that a little bit better, then it might come easier to you. My suggestion is honestly for these, they're just a little tricky to try to even do it using shortcuts. So my suggestion is to pick a value within the range that they're giving us within that domain and then see if it works. So, and then again, you have to make sure that like you're trying everything. So, just because it works for one doesn't mean that that's the answer, because some of these, it can be, it can work for multiple. Okay, so I want you to look at what we've got going on. We've got this graph that gave me an equation, and they're looking here and they're saying, okay, well, we're looking at our domain being from 0 to a to b to 2 pi. Now, I want you to look here. You see how 0 is less than or equal to a, right? And then over here, b is less than 2 pi, meaning b cannot actually equal 2 pi. If you read that, it does allow you to get rid of one of these answer choices for this problem, because over here, this can't happen, right? B cannot be equal to 2 pi. So this is not going to work, okay? But that still leaves me with 3 answer choices. It does make it to where it's a little bit better for us, but it still leaves us with 3 answer choices. All right, let's look at what we've got. Let's try to plug in some values. I've got a range right here. This domain is going from 0 to pi over 2. So again, that's looking in this first quadrant. Now you cannot make a statement about this based off of, I'm looking in this quadrant, is there a graph there? Okay, that doesn't work that way. So don't fall into that trap. Because if things are negative, they end up going the opposite direction than you anticipate. And anyways, you just got to watch out. So anyways, you might start getting to where you can recognize some things if you know, oh, it's negative, and then be able to kind of like use that to your advantage. But I'm just going to say, for the purpose of keeping it as simple as possible, we're going to keep a similar method to what we did on the last thing. I just have to pick a value that's in this range. So if y'all look here from 0 to pi over 2, I'm going to pick something within this range. And honestly, I'm going to pick something within this range that's easy to calculate, because some of them are not. If I don't have a calculator, what's going to be the easiest thing to do? If I'm calculating sine, the easiest thing to calculate sine of within this range is pi over 6. So I'm going to say, just as a note, plug in values in the interval. And again, what I would say here is let's try f of pi over 6, because pi over 6 is easy to do sine with, okay? That's literally the reason why. I don't have a better reason. Okay, let's try it. Sine of pi over 6 is going to be 1/2. And if you do negative 3 times 1/2, it is negative 1.5 or negative 3/2. Okay, so let's check and see, is this on there? At pi over 6, are we at negative 1.5? Negative 1.5 would have gone here-ish, okay, at pi over 6. So no, that's not the correct point. Not right. Then you can try another one. Now I want you to watch these two, because these two domains, do you notice how they both end at pi? But this, B starts at pi over 2, and C starts at 0. Now, I want you to think about the fact that pi over 6 is in this domain right here, right? So since pi over 6 is in this domain, and we know that doesn't work, then this can't be the answer. Okay, so you're going to be able to like narrow this one out because of the fact that we know pi over 6 didn't work. Pi over 6 was in this domain, and because that didn't work out for us, then that can not be an answer, which leaves me with B, by process of elimination. So you can plug in a number for all 4 of them. If you don't recognize any patterns, you can plug in stuff for all 4 of them. But honestly, it's very possible that you could try plugging in something that works in both of these, because 0 to pi is the whole top section. Pi over 2 to pi is just this piece right here. If I chose to plug in like 5 pi over 6 for both of these, it would work in both of those cases. It's in both of those domains, and it would work. So it'd be hard to narrow it down. So what we do know is pi over 6 doesn't work. So we'll go ahead and just go with that. All right, y'all, that is going to be it for this video. There are some more problems here that you can try, and I would encourage you to try them and then check with me in class. But for the purpose of this lesson, we are done with this. I do want to reference, I may have done this in the last video, but I want to reference the back page of our packet, where you can see we have all these different functions that you can recognize, and they have their little equations that go with them. There's a project that I'm assigning, and you guys might end up using these to help you out with some of that. So just got to keep that in mind. One other fun fact is Desmos doesn't really care so much to use an R squared. So to kind of get around that for this lemniscate, you can do a square root, and it should work out for you. Okay. All right. All right. That's it. I will see y'all in the next one. Bye.